In this video, we are going to look at question 52 from the specimen paper.
In this question, a crane is lifting a mass, and we are given the graph of height versus time. So we can see that there's lifting going on, the height increases with time, and from the graph, we can see that there is a region where the line is almost a straight line with a gradient of 0.5, and we'll see that that will be important later on. And the last piece of information is that the mass of the load is 20 kilos. Our task is to find the power output of the crane at time equals 10 seconds, so here. The power, by definition, is the change of energy with time, or the work done per unit time. And the work done during the lifting must be equal to the change in the gravitational potential energy. So the change in the gravitational potential energy, the time derivative of the potential energy, must be the power output of the crane. And since the gravitational potential energy equals mgh, we can differentiate that, and the only non-constant quantity there is the height. Mass remains constant, and gravitational acceleration is of course constant. We see that the power must be mg dh by dt. And why was that the right thing to do, the right way to think about this question? Well, because dh by dt is something we can read off the graph. That's the gradient of the line of h against t. And we see that the gradient here is 15 divided by 30.5. So when you plug that in, 20 kilos for the mass, 10 meters per second gravitational acceleration, and 0.5 for the change of height with time, that's speed basically. And in fact, another formula you might know for power, force times speed, that's just the same thing, written differently. So all of that gives us that the power which the crane must supply at time equals 10 seconds is 100 watt. And in the exam, that was option D.